let's go. So, oh, we got more people. Gael coming in. All right, the recording has started. So, basically, y'all had some questions about how to do these additions and subtractions, okay? So, if I can, hopefully everybody in the meeting can see that I've got a really big rational expression here, all right? And so I made a video yesterday, two videos, put it onto the Google Classroom, and I explained how I kind of go through these. I didn't use that box that we did on the notes. Excuse me. I used a slightly different technique, which I was hoping some people might find more clear and beneficial. So, when we have to add these things and subtract these things, our goal is to get a common denominator, all right? So clearly none of these guys have the same denominator, right? I got x squared, I got 3, x squared plus 3 minus 18, I got a 6 over here. So none of these are the same, right? So what a lot of students do is they multiply, for example, they'll multiply this up into here and this up into here as well, okay? But the problem with that is you're going to potentially create an enormous polynomial in the numerator and in the denominator. So, in order to make this as efficient as possible, you want to factor first the denominators. So I'm going to first factor the denominators, okay? So I'm just going to rewrite this, and this is x minus, plus 6 and x minus 3, okay? Plus a 1 over x plus 6 minus a 1 over x times x minus 3, okay? And so now, as you kind of see here, we've got several factors that are common in the denominators here, all right? So I'm going to highlight them. I've got an x minus 3 and an x minus 3, all right? So that's there, all right? And then I've got, let's see, an x plus 6 and an x plus 6. And then I've got an x and an x. So that's basically my common denominator. So I'm going to write that down. X plus 6, x minus 3, and x. And I've effectively covered all of my factors, and they are currently sitting in the denominator. Okay? Now, our next stage is to take care of the numerator. All right? So I'm going to maybe break out a green color. The numerator has the following stuff already in it. Notice I'm highlighting it in green. So I'm going to go ahead and write that stuff down. All right? I'm going to write that stuff down. So it's x, and I'm going to leave a space plus 1. I'm going to leave a space minus 1, and I'm going to leave a space. So notice what I did there. I just copied all of that stuff down in green. X plus 1 minus 1. So x plus 1 minus 1. And this space that I left over will contain in it, I have to write down all of the factors that are not in the denominator that this fraction is representing. So this is the first fraction. So as you can see, this first fraction has the purple and the blue factor. Okay? So it is missing, I said that wrong, the purple and the yellow, right? So it is missing the blue factor. So therefore, I have to write down the blue factor, all right, in there. And this one here has the blue and the purple, so it's missing the yellow. So I have to write down the yellow. And now the last fraction has the blue and the yellow, but it's missing the purple, and so I have to write down the purple, okay? So if you're looking closely at this, you can see that I've got a purple here. I've got my yellow factor was here, and I've got my light blue factor over here. Now, that right there is, in a way, the top of the mountain, if you will. It's kind of like the most. Once you've reached this location, then once you've reached this location, you have now kind of achieved sort of the most of what you need to achieve. Okay. So, what you want to do at this point is now simplify all of this numerator here, and I'll circle it in orange. All of that stuff now needs to be simplified, okay? So I'm going to go ahead and do that. X plus 6, x minus 3, and x. I'm just rewriting the denominator, okay? Now, if I simplify this stuff here, the x and the x times x is x squared. Plus, now, if I simplify this, hey, is everything okay over there, guys? I'm hearing some questions or something. Okay. So if I so in the next situation, I've got a 1 and an x minus 3. So I'm going to multiply that in. 1 times x minus 3 is just going to be simply x minus 3. Okay. This negative 1 distributes into here. So I get a minus x minus 6, or a negative x minus 6, however you want to say it. And now, as we move further down in this question, at this stage in the game, we only have really very few things left to do, and that is we must combine some like terms, okay? So I've got an x and an x, those are like terms. I've got a negative 3 and a negative 6. Those are also like terms. And so we're going to basically do that. X squared, x minus x is positive x minus x is simply just 0x, so plus 0x. So, as you know, we actually don't have to write that because a minus x and a positive x cancel each other out. And I'm left with minus 3 there. So minus 9, 9. Because my negative 3 and my negative 6 combine for a negative 9. Okay? So I've got x plus 6 here, x minus 3 here, and x. And now we're effectively finished with this. All right? I do have some restrictions to write down, that x cannot equal 6, cannot equal positive 3. Sorry, it was a negative 6 there. And that x cannot equal 0. All right? There is one more thing that we can do here. Now, at this stage, you can factor the numerator if it looks factorable, and you can cancel anything that is remaining. All right? And look, as you all may have noticed, this x minus 3 cancels, and so I'm left with x plus 3 over x plus 6 times x. Okay? So that's kind of the idea there. Okay? Any questions on that one there that anybody might have? Hello? Anybody there? Okay. Hey, can you guys point the camera down so that it's facing the room there a little bit? So I can see folks? Okay, perfect. Yeah, yeah. So I don't know if that's a little bit more clear. Shall I do another one of those potentially? Okay. I'll go get one from up here. So, let's see if I've already done a few of these here. I'll do one of these ones with 3. I think I did some on yesterday's video. I'll do this one over here, number 84. Okay. This one's a little bit smaller in the end. Okay. And I'll just paste it here. Okay. So here it is. This is a pretty simple one. It's 4 plus just a very simple fraction. Okay. This one, these styles here can be a little bit more. You can kind of overcomplicate these, but you can also make this one pretty simple and easy right at the get-go. All right. This one, because the 4 is not a fraction, right? You kind of pretend like it's got a 1 as the denominator. So you're saying this is like 4 over 1 plus 5 over x minus 7. And essentially what you want to do is multiply an x minus 7 over an x minus 7 into this fraction. Okay? And remember, I think I did this one of the other day where I kind of just multiplied a random, what seemed to be a random factor into, some number. What this effectively does is it automatically produces a common denominator, okay? Because as we know now, multiplication of two fractions here, so these two fractions are going to get multiplied together, these ones. And when I multiply two fractions, this is going to be 4x minus 7 over x minus 7 times 1 plus 5 over x minus 7, okay? And that's what we have, okay? That's what we've got. Now, you might notice that this one now currently automatically has a nice little common denominator, okay? And so I'm going to go with 4x minus 7 plus 5 over x minus 7. So this one is now pretty much done. It's 4x minus 2 over x minus 7. This is good. The restrictions are x cannot equal a positive 7. Okay? You might say, well, do I need to factor the numerator? You can, and if you do, you would get the following: 2x minus 1 times 2, right? Oh shoot, thank you. Good job. 28. There we go. Thanks, Lisa, or whoever that was. 28 minus, and then negative 28 minus 5 is 23. Is that right? Plus 5. There we go. It's not erasing. There it goes. 25. 23, actually. 23. All right. Okay, so then therefore it appears to be non-factorable in the numerator. So we'll leave that like that. Yeah, I would have missed that one for sure. So those ones are pretty simple if you kind of do this fancy rule that we did here, where you're basically just multiplying by an x and minus 7 over an x minus 7. Okay. Any other questions that folks might have? So what I'm going to do is I'm going to pull a couple out of maybe the textbook at this point, okay? And, just some simple ones here. I'll do, for example, one that happens to have let's see, I'm going to multiply this through. No. All right, well, I'll just erase that. There we go. So here's one where we've got a little bit of a mix of different things. We've got some additions, we've got some subtractions, we've got some multiplications as well, okay? So what happens if you end up seeing something like this? It's kind of like a 2b minus 5 over, I'll just make up something here, b squared, 2b minus 15. I'll pull something out of the book, but I'm going to make some changes on it so that it's a bit different. Okay, and then we got multiplied by a b squared minus 8b plus 12 over b plus 3. So this one looks pretty big here to start with. Question is, how am I going to deal with this first? All right. What are my what are my stages here? I've got an addition, then I've got a multiplication. If y'all remember, we have to do multiplication before addition due to the order of operations. Okay, and so we're going to get a 3b minus 5 here, and a b squared minus 2b minus 15. Plus, what I'm going to do is multiply these guys first. Okay? And I'm also going to look at factoring these ones as well. Let's see if I copied all these down correctly so they factor nicely. They do, it looks like. So I've got a b times this factor here, which is going to be 12. I guess I'll do 6 and 2. So b minus 6 and b minus 2. That's basically the factorization of that trinomial there. Okay. Then furthermore, I'm going to factor this other trinomial, b squared plus b minus 30. 30 is 6 times 5, so I'm going to go with b plus 6, I guess, and b minus 5, okay, and times a b plus 3. All right, so where does all that coming from? Remember in our previous section, when we multiply things, we multiply the numerator and the denominator. So I multiplied this denominator with this denominator, and I multiplied this numerator, b, with this numerator here. Now I've got an addition question. This one looks to be a bit of a pretty large addition question, okay? So what I'm going to want to do here is, I guess, factor this guy here at the bottom. So this is going to be a 5 and a 3, okay? So I'm going to write 3b minus 5 over 2 factors of b, and I'm going to go with a negative 5 and a positive 3. So you might say, well, where's that coming from? That is this guy factored, all right, plus, and I'm just going to rewrite this. I probably should have factored earlier, but I've got an infinite amount of space on this piece of paper here, so no big deal. B minus 5 and b plus 3. Now, what we want to do is we want to start to recognize what are our common factors, because I'm going to now have to move into addition mode. I'm moving into addition mode here. So there we have it. And so I'm going to recognize that I've got a couple of factors here: b plus 3, b minus 5, and b plus 6. Well, this doesn't look like a 6. It is. There it is. It's a 6. So if you kind of look closely, I've got these 2 pink factors, and then I've got, let's make a, I don't know, a sort of a gray factor. So there it is. I've got a gray and 2 pinks. Okay. Now I write those as my common factors. So b plus 6. This becomes now my common denominator. B plus 3 and b minus 6. And again, now what do? We multiply into the numerator thanks. It's a 3. Thank you. Good job. Nice work. And so now what do? We notice that I had the 2 pink factors in the first fraction, and I have to multiply in the gray factor. Where do I multiply it? I have to multiply it up into the numerator, right? So how I was showing you before is you kind of take this and you write these guys down in my numerator, leaving spaces where necessary, okay? So I'm going to write my 3b minus 5 here, okay? Oops, that's supposed to be a minus. And then I'm going to leave a space so that I can multiply in. The plus goes there. And then this is just going to be a b minus b plus 6 and b minus 2 there, okay? Now, what gets written here, it's the gray factor gets written there, and b plus 6. Why? Because over here, if we kind of go back to what we were doing before, it's kind of like I'm taking a b plus 6 and I'm multiplying it, b plus 6 and a b plus 6, and I'm multiplying it into the numerator and the denominator here. And it basically produces my like denominators. Okay, one thing I missed was the parentheses here. And now, essentially I'm done with this one, except that I really ought to simplify the numerator, okay? So this is going to be a bit of a work here, so I'm going to FOIL a bunch of this stuff here, all right? And like that, all right? So I'm going to get a, try not to make a mistake. 3b squared is 3b times b, and then I'm going to go 3b times 6 is plus 18b minus 5b minus 30 plus, okay? The plus is the blue plus there. Now I'm going to do all of this stuff multiplied together as well. So b times b is b squared, all right, minus 6b minus 2b plus 12, okay? Then there was also this b here that needs to be multiplied in. So if I do that, each one of these becomes bigger. So this becomes b to the third, this is a b squared, and so forth, okay? And there, this is now what we're looking at, okay? And I've got some common like terms here. My squareds, okay? And I've got a couple of b's, just regular old b's. There, there, and there, okay? And then I got a b to the third and a negative 30, okay? So my b to the third, oh, I forgot my denominator, guys, here. B plus 6, b plus 3, and b minus 5. So now moving down, most people would write the b to the third first and the negative 30 last, okay? Then I write my b squareds, so 6, 8, negative 6 minus 2 is negative 8. Add 3 to it, minus 5b squared. 18 minus plus 12 is 30, so 25 minus 25b. And this, I could multiply the bottom as well, but honestly it's not that big of a deal. We can kind of leave it like this, all right? This is okay as well, all right? Now, any questions on that one? It's pretty clear. You know, there was several people expressing some concern on the additions and the multiplications. Anybody still concerned about the procedure in general? There was a lot of people yesterday who were concerned about the additions and the subtractions. That, you know, a couple of students said, "Oh no, I'm not getting the addition and the subtraction," and I was just wondering if anybody is still having some issues with it. It seems to be. Is everybody okay following along there? Or are folks doing other stuff? Yeah. As I hear, yes, that's perfect. Let's do 105. Okay. Good. I hear some chatting over there. Are you guys causing some ruckus? Who's that? I hear some people talking over there? Are people asking questions, or are they just doing some random chat talking? Ah, okay. Are we sure here? Okay. Guys, seriously here, I don't want you guys taking advantage of the fact that I'm not there, okay? Please. Which one did you want to do there? Okay, we'll try 105 there. Okay, I'm going to move down here. Well, this is going to cause trouble. Well, I'll do it like this. Push that one down. Give myself a fresh page here. 105. Here it is, 105. Okay. So again here, this is we got an addition and a multiplication. So what we want to do in this one is take our denominators and factor them. Because if we realize that there's going to be common factors in some of these denominators, okay, there might be a factor over here that's also over here, and one that's here that's also over there, okay? So the reason why we want to do that is because duplicate factors, we don't want to multiply them in too many times, because our final rational expression will be too large, okay? So our first goal is to factor the numerator and the denominator. If you don't, you will likely end up with an enormous numerator, okay? So go ahead and factor it. You're going to save yourself a bit of time here. So I'll quickly factor each one of these. All right, this is the stuff that we did on the test last week. And so it's x and x. Here I've got another x and an x. And what I can do here now is, I don't know, 24. Positive 24 is going to be 6 and 4. 6 times 4 is 24. So I'm going to go plus 6 and plus 4. Okay. Then I've got over here a 32. What is that? 8 times 8 times 4 is 32. Is that right? Which gives me also a 12. Okay, x plus 4 and x plus 8. And look, already we discover that there is a common factor of plus 4, which is going to be beneficial in our final situation here, okay? I'll factor the others, and you know what I guess? I bet this is going to be a 6 and an 8. The reason being is because, look, this is x plus 6 over here. This is x plus 8 over here. And so I'm going to multiply those guys through. And look, 6 times 8 is 48. Okay? Look at this. It's always the same pattern. Why does this textbook do this for us? Because they don't want your final answer to be enormous. And so look at what they've done here. They've really conveniently given us a bunch of factors that have a mix of commonalities between themselves. Okay? And it's just sort of doing us a favor, whoever wrote this question. Okay? So now that I've got these guys factored, okay, I can have my bottom x plus 6, x plus 4, and x plus 8, okay? And those are my common factors. The 6 is blue, the 4 is purple, and The 8 is yellow, okay? Now, if you're remembering my past, the couple of questions that I've done in the past, what I did at this point is I highlighted the numerator, okay? Because then what that allowed me to do is write x, leave a space, plus 4, leave a space, minus 2, and leave a space. So if you look closely, that's really just getting transferred down. The space is left there, remember, to multiply in the factor that is missing from the denominator, okay? So I've got x plus 8 that was missing in the first fraction, and so therefore I have to write in the yellow x plus 8, okay? The second fraction is missing the blue, so I'm going to have to write in the blue. And the third fraction appears to be missing the purple, so I'll write in the purple. Once you've gotten this far, x plus 8, let me just copy this down, x plus 6, and x plus 4. Once you've gotten this far, you've effectively achieved the learning goal and the success criteria for addition and subtraction of rational expressions, okay? The rest of the question, though, is just doing a little bit of simplification, all right? So this right here is now the if you will, the top of the heap, or the, you know, I guess the, I don't know, you're going up a hill, and now the rest of this is all just downhill, where you're simplifying what you're looking at, okay? And so you're going to have to use your traditional simplification rules. This stuff here simplifies to x squared plus 8x, because I'm going to use the distributive property by distributing this x into here and here, okay? Now my positive 4 and my 6, x plus 6, same thing. Distribute here and here, so leaving me a plus 4x plus 24. And now this one, the negative 2 distributes in as well, leaving me a minus 2x minus 8, okay? And I've got x plus 6, x plus 4, and x plus 8, all right? And a final, just a little bit of housekeeping, is traditionally people would feel inclined to combine like terms here. So I've got my x squared that has no like terms, so I'll leave it. I've got my 8, my 4, giving me a 12. Then this 2 can combine in as well, so bringing it back down to 10. 10x, whoops, that's an 18. It's supposed to be a 10. And then I've got a 24 and an 8 that end up giving me a 16, okay? And there we have it. X plus 6, x plus 4, and x plus 8. This is now done. Oh, don't forget about restrictions. I think I forgot restrictions in the previous question, but try not to forget the restrictions. We can also see if the numerator factors here. So 16 is 8 and 2, right? But it's negative, so I don't believe it's going to factor, okay? So that's not gonna work out. All right, my numerator. So you could leave it like this. A lot of textbooks ask you to multiply the bottom out. I'm not super concerned about that right now because I already tested you guys on that. So as long as you get the addition and the subtraction down fine, then we're okay with that. All right. I think I got that one right. If I messed anything up, somebody could point it out for me. A lot of numbers flying around. There is a lot of potential to make mistakes in these questions, ladies and gentlemen. And I understand if you make a little error here. What you want to do is you want to have your work nice and organized so that me, the guy grading it, can look at it and clearly see that you have a good degree of understanding with on how this works. So how do you do that? You just have your work be really organized, and I'll be able to give you like some partial credit and things like that. I do that in order to coax students into organizing their math really well, because I know, and I've seen over the years, students who have organized math learn new math more efficiently than students who have difficulty organizing their math. So in a way, I kind of, try and award points for organization, if you will, and so that's something you want to keep in mind. Okay, let's look at number. Moving down, 106 as well. This one looks pretty fun. Okay. You might say, man, this is some crazy stuff, Mr. Knapp. When am I going to see crazy stuff like this? Well, if you ever find yourself in a calculus course, or if you're going to be in engineering, then you will find some skills like this very helpful. There's something called partial fraction integration, which is kind of a skill that you're going to use this for. We also do things like this when you're trying to find, there's a lot of optimization questions that involve addition and subtraction of rational functions. But again, this is only if you're going to get into some introductory level calculus courses. If you're, and who does that? Folks who go into the sciences and the engineerings, right? So keep that stuff in mind, that this isn't necessarily like a waste of your time. So do the best you can on these guys. It's always good to increase your algebra skills as well. Because like I always say, being good at algebra makes you really popular when you go to parties and stuff, right? So keep that in mind. Now, we've got this is another one. I'm going to try to keep the same approach here. Okay? And I'll go back, after this one, I'll go back and I'll do a more simple one. And I'll use the same approach again, so that you kind of see how this technique that I'm doing is going to be used in all cases. All right? So I'm going to factor my denominator and my other denominator and my other denominator. We're getting a 12, which is, what's 12? 4 and 3. So -4, -3. You're going to get a lot of practice factoring when you prepare for this test, right? Let's see, -3 and -1. And then again over here, we're going to get a 4 and a 1. A -4 and a -1. Oh gosh, again, they're very nice to us. Look at what they've done for us here, is they've basically given us a free pass here, and they're kind of just giving us some of the same factors, okay? So that factor needs to get written in my denominator, okay? The yellow factor should get written in the new denominator. And we'll go with light green factor should also get written in the new denominator. So as you can see, we've got x minus 4, x minus 3, and x minus 1, all up in the denominator there, okay? Now, I think I've been using blue in many cases, or green. I take these guys and I write them down. So it's going to end up being a x, leave a space, minus 2, leave a space to multiply, plus 3, and leave a space to multiply. Okay? And you again just have a similar pattern here. All right? Purple, yellow, those are the factors that we have. So that means you're missing green. So you go ahead and you put in the green factor. Okay? Then in the middle one, you've got yellow and green, so you're missing the purple factor. And in the last one, you've got purple and green, and so you have to put in the yellow factor. Okay? And so it's going to be x minus 1 here, x minus 4, and hopefully I don't mess this up, x minus 3. Okay? Multiplying all of this through, now we're simplifying. But again, at this stage in the game, you've now effectively completed the getting the common denominator thingy that you got. So we're going to now distribute, okay, distribute, and distribute. And there, it's just going to be x squared minus x minus 2x squared plus 8 plus 3x minus 9. I just distributed those guys. And now yes, thanks. I was going too fast on that one. Good job. X minus 4 and x minus 3 and x minus 1. A couple of like terms here are going to be x squared and 9. Those guys are not like terms. I've got a couple of x's. I've got 3 of them, it looks like. And 3 to the x. Oh no, the 9 and the 8 are like terms. The 9 and the 8. So I got a 3x. Oh, look, these guys cancel. Look at this. A negative x, a negative 2x is a negative 3 plus 3. All the x's cancel. These guys. Boom, boom, boom. Leaving me 8 minus 9, which is minus 1. Minus 1. We got an x minus 4, an x minus 3, and an x minus 1. I'll factor my numerator here, and I'll get x minus 1 and x plus 1. That's the difference of squares. Okay? And you're going to see that I just, by sheer coincidence, got a common factor in the numerator and the denominator. Okay? Doesn't always happen, but sometimes it does. And there's our final answer there. Let me move that one away. And we're done. X minus 1 over probably want to do restrictions. Again, I think I forgot restrictions on the previous one. But restrictions are going to be x cannot equal 3, 4, and a 1. Okay. You'll want to look closely at the directions. If it says please state the restrictions, then yeah, go for it. So what I'll do is when you turn your test in, I'll try and remind you, hey, did you get all those restrictions? Hey, so then as you turn it in, just be like, oh wait, let me just double check, okay? And so then you'll just go through and kind of like all the denominators, basically. Just look at every single denominator and make it into a restriction. And after you get good at it, you can start doing all those in your head, right? That's the idea. Right? You know, like, just take this number and change its sign, okay? Still got another about 15 minutes. I'm going to pull another one, maybe from here, maybe. Something real. Maybe number 67, right? Number 67. Was that, did somebody have a question there? So here's another one. 7x squared y and x y5. Okay? Y to the 5th. I think I said that wrong. It's 7 over x squared y squared plus 2 over x y to the 5th. Okay? So again, here, I'm going to factor the numerators and the denominators. Sorry, just the denominators. Okay? So this is going to be x times y times y. It's going to be x times y, 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 y. Okay? Putting a 2 there and a 7. So here you might say, well, how do I going to deal with these colors? I got to, there's a common one. Okay? And let's see, here we got y squareds are common. Okay? And now the stuff that's missing from one should get multiplied into the other. Okay? So I'm going to stop here. Notice this has 2 x's, this only has 1. And so this guy needs to be multiplied up into here, this x. This has 2 y's, this has 5. So therefore, this first fraction is missing 3 y's. So I'm going to multiply them all up into here. Okay? So I'm going to get 7 y to the 3rd plus 2x over x squared y to the 5th. Whoa, what happened there? Remember, I took these 3 and I multiplied them up into here. Okay? Then I took this 1 and multiplied it up into there. Okay? Yes. Let's see. No, there are 5 of them. Look, 1, 2, 3, 4, 5. You see that? Here. I don't know why I did it like this. Here, I'll show you. Oh, my program froze up a bit. Let me, hello, program. Come on. Okay, did that make sense, Gaia? For some reason, my program froze up. Yo, maybe it all froze. There, I'm going to close it and open it back up. There. Okay. So I think it was because there's a bit of confusion because of the way that I did this here. I'm not sure why I did it like this, but it was a Y and a Y. Okay. And I don't know why I did this, but I should have highlighted these two Y's. Okay. And as you can see, there's a total of 5 of them. 1, 2, 3, 4, 5 Y's, because this is Y to the 5th up there. Not necessarily. It's all the biggest one, right? So it's kind of like these ones here now end up getting multiplied into here and here, right? Right here, Y to the 3rd. And then this X here, which I guess I'll do, I'm running out of colors. I got a blue, blue, and blue. Okay, and so now if you look closely, the bottom of this one has a Y to the 3rd plus 2 more Y's, so Y to the 5th, and it's got 2 X's. This one has a Y to the 5th and also 2 X's. Then the stuff that got multiplied in on the bottom in order to achieve that must also get multiplied into the top. Okay, so does that make sense? Okay, I'm going to do another one of those, because I spent a lot of time on the bigger ones and I glazed over these smaller ones, so I don't want students to miss out on these as well. So let me go get, for example, whoops. Do we have one? Here's one. I mean, I could just make one up at this point too, right? So copy. Okay, we'll do number 68. All right. All right. So first off, I'm going to factor. So 3 minus 2. I've got 4 A's. 1, 2, 3, 4 A's. 7 B's. Oh my. Let me do it like this. 3, 4, 5, 6, 7. Okay. Now again, you don't have to do it like this if you've got sort of a shorter technique. But I'm going to do, 5 A's, 1, 2, 3, 4, 5 A's, and 1, 2, 3, 4 B's here. Okay? So now, if you look closely, I've got 4 A's here, 4 A's here, meaning I've got 1 A missing. So I'm going to have to put it in here and here. Okay? And it's all about like what you're missing and stuff, okay? This thing looks like a B right here, but it's an A me get rid of this one. Change them back into a B. Okay, so now let me focus on my B's. All right, I've got 4 B's here, 4 B's here. So as you can kind of see, I'm missing 3. So that means I got to put in 3 here and 3 here. So B, 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 and B, B, B. All right. Now, if you look closely at both of these denominators, they have exactly the same amount of stuff. This one's got 5 A's, 7 B's. This one's got 5 A's and 7 B's. So my now common denominator is A to the 5th, B to the 7th. And like Gaia just said, it's the biggest one. So notice the biggest one is B to the 7th. And the biggest one here is A to the 5th. And then if you were smaller, you ended up getting it. So now you got to clean up the denominator. It's just going to be a 3a minus 2 times b to the 3rd. You might say, well, where does that stuff come from? That's basically this stuff here. Okay, all up in there. All right. So again, those are the smaller ones, which again, you know, like I said, because if you spent a lot of time on the big ones, the bigger questions towards the end, you might miss out a little bit on some of these smaller ones. All right. Getting a common denominator. Oh, right, thank you. I seem to be forgetting those. A and B cannot equal 0. Because it's basically like A, if I make A 0, then over here, if I plug it in, then I've got 0 to the 4th, which is a 0, and I get a 0 multiplied into my denominator. Okay. Same thing with B. We got some time to do another. These ones here have like denominators pretty much already. Let's do, for example, this one, 76, looks like to be a little bit of a fun one. This is maybe medium level difficulty because of this negative in front. Okay, a lot of students are going to get a little bit of, nervous about that. But honestly, we've got the same idea here. I factor my denominator and my other denominator, but these are already factored as low as they can go. Okay, you can't factor x any further. And you can't factor x minus 4 any further. So you basically already have your common denominator of x times x minus 4. Okay? And I'll highlight my two things. That one and this one. Okay? So basically this one is missing the pink. So I've got a minus, hold on. I'm gonna try and do this exactly the way I do the bigger ones, okay? So now I write the green stuff. -5, leave a space, plus 2, leave a space. So -5, leave a space, plus 2, leave a space. So I've got my x minus 4 gets multiplied into here, because it's the pink one. Well, that was supposed to be pink. And then my blue one gets multiplied into here. Okay? So there it is. We're effectively done with the addition subtraction portion of this question. Now I just have to distribute. And I end up with the final answer. So negative 5x plus 20 plus 2x over x times x minus 4 keeps moving around. And finally I've got a 7x plus 20 over x times x minus 4. I think I got that right. Restrictions. X cannot equal 0 and x cannot equal 4. Where are these restrictions coming from? The x gives me that restriction, and the 4 gives me that restriction. Like terms. We had some like terms, yeah. The 5 and the 2, I got them as an x. Yeah. Okay. Nice job. So yeah, that's kind of it. So we did a lot of smaller ones. We did a lot of bigger ones. And like I said, I videotaped all this. Looks like it is 1 hour and 7 minutes. It's going to take maybe an hour or two in order for it to decompress and do all that funny video stuff that videos do. And I will post it onto my somewhere onto the Google Classroom, okay, in a bit. Okay, I'll stop the video now.